Have you ever wondered, what's the most massive star in our universe? Picture this. A celestial body so enormous it dwarfs our own sun, a mere speck in comparison. It's hard to grasp, isn't it? The sheer vastness of space, the infinite cosmos, teeming with a multitude of stars, each one unique, yet all sharing a common origin. The topic of our discussion today is not just any star, but the most massive ones. Those that truly embody the phrase, go big or go home. These are the behemoths of the cosmos, the giants among stars, their size, their luminosity, their sheer gravitational pull. It's all on a scale that's hard for us to comprehend. These celestial titans hold secrets about our universe that we're still unraveling. They're not merely distant lights in the sky, they're the building blocks of the cosmos. So, buckle up, fellow cosmic voyagers. Well, today you are about to discover just how incredibly massive these celestial giants can be. When we talk about massive stars, we're not just talking big, we're talking colossal. Ever gazed up at the night sky and wondered just how big those twinkling dots of light truly are? Well, let's dive into the realm of the truly gigantic, the massive stars. A star is classified as massive when it exceeds 8 solar masses. Now you might be wondering what a solar mass is. Simply put, one solar mass is equal to the mass of our own sun. It's an astronomical unit of measurement that helps us comprehend the staggering scale of objects in the universe. So when we say a star is 10 solar masses, we're saying it's 10 times the mass of our sun. Sounds enormous, doesn't it? But here's where it gets truly mind-boggling. Some of the most massive stars we've discovered are over 100 solar masses. That's more than 100 times the mass of our sun. Now, let's put it into perspective. Our sun, a pretty average star by universal standards, could fit 1 million Earths inside it. Try to imagine a star that's 100 times more massive than that. It's a scale that's almost impossible to fully grasp, isn't it? But it's not just about mass when we talk about these titans. These stars also have a much larger volume, meaning they physically take up more space. While a star like our sun might seem impressively large to us, a massive star would dwarf it in comparison. These celestial giants are not just larger and heavier, they're also brighter, hotter, and have much shorter lives than smaller stars. Their sheer size and mass mean they burn through their nuclear fuel at a much faster rate, leading to a shorter but far more dramatic stellar life. So when we say a star is massive, we mean it's many times larger than our own sun. The universe is filled with these titanic celestial bodies, each one a testament to the awe-inspiring scale of the cosmos. But what makes these stars so special apart from their size? Well, there's quite a bit to unpack here. When we talk about massive stars, we're not just referring to their size. Massive stars are fascinating for a number of reasons. They're not just big, they're also incredibly bright, and they don't stick around for very long. Let's start with color. Stars are not all the same color, they can range from red to blue, and this color tells us a lot about the star. Massive stars, the ones we're talking about, are typically blue. And why is that? Because blue stars are the hottest stars in the universe. The color of a star is directly related to its temperature, and blue stars can reach temperatures of up to 30,000 degrees Celsius. Now that's hot. Next, let's talk about brightness. Massive stars are incredibly bright, much brighter than our sun. The brightness of a star is related to its size and temperature. A larger star is going to be brighter simply because there's more of it to shine, but a hotter star is also brighter because it's burning its fuel more efficiently. So, a massive hot star is going to be incredibly bright. Finally, we come to lifespan. And this is where things get interesting. Despite their size and brightness, massive stars don't live very long. They burn through their fuel at an astonishing rate. You see, a star's life is a balancing act. It's constantly trying to balance the force of gravity pulling it inward with the pressure of the nuclear reactions pushing outward. The more massive a star is, the more fuel it has to burn to maintain this balance. And so they burn out quickly. In other words, the bigger they are, the brighter they burn, but the quicker they fade. Now shall we meet some of these celestial giants? Imagine a star so enormous that if placed at the center of our solar system, it would engulf Jupiter, or even stretch beyond it. This is not the stuff of science fiction, but the reality of some of the most massive stars in the universe. First, let's introduce R136A1. This behemoth resides in the Large Magellanic Cloud, a neighboring galaxy to the Milky Way. R136A1 is the most massive star ever discovered, weighing in at over 260 times the mass of our Sun. And though it's not the largest in terms of size, its luminosity is truly staggering. It shines with the brilliance of nearly 9 million suns, making it one of the most luminous stars known to mankind. Now let's shift our gaze to Scooty. This star holds the record for being the largest in terms of size. Located in the constellation Scutum, Scooty dwarfs our sun in a way that's hard to comprehend. If our sun were the size of a basketball, Scooty would be as large as Mount Everest. It's so big that light would take about 7 hours to travel around its circumference compared to a mere 14.5 seconds for our sun. These stars are incredibly hot, with surface temperatures reaching up to 50,000 degrees Celsius. That's more than 9 times the temperature at the surface of our sun. Their lives are fast and furious, burning through their nuclear fuel much quicker than smaller stars. Massive stars like R13601 and Scooty are not only fascinating in their own right, but they also play crucial roles in the universe. They are the primary sources of heavy elements, seeding the cosmos with the building blocks necessary for planets, and eventually, life. These stars are truly the titans of the universe. So, what happens when these massive stars reach the end of their lives? Well, the life cycle of a star is a fascinating journey, filled with cosmic transformations. Massive stars, often several times the size of our sun, follow a distinct path. They are born from clouds of gas and dust, and they shine brightly throughout their lives, burning their fuel at an astonishing rate. But when they exhaust their nuclear fuel, things get really interesting. You see, unlike smaller stars that gently fade out, these colossal celestial bodies go out with a bang. Literally, they explode. This explosive end is known as a supernova, an event so bright that it can outshine an entire galaxy. For a few weeks, a single star can radiate as much energy as the sun will in its entire lifetime. Imagine that. But sometimes a supernova just isn't enough. The biggest stars, the real giants of the universe, may end their lives in an even more spectacular fashion. These stars can cause a hypernova, an explosion so powerful it's like a supernova on steroids. Hypernovas are among the most energetic events in the universe, releasing a mind-boggling amount of light and radiation. After the fireworks, what's left of the star undergoes a transformation. If the remaining core is very massive, it collapses under its own gravity to form a black hole, a region of space where gravity is so strong that nothing, not even light, can escape. If the core is less massive, it may become a neutron star, an incredibly dense object made almost entirely of neutrons. So, the fate of a massive star isn't a quiet fade into the cosmic background. No, it's a spectacular finale, a cosmic performance that can outshine galaxies, create black holes, or form bizarre neutron stars. The death of a massive star is as spectacular as its life, leaving behind some of the most fascinating objects in the universe. So, what have we learned about these celestial giants? We've journeyed through the cosmos, brushing past the universe's colossal stars. We've marveled at their immense size, dwarfing our sun by hundreds of times. We've delved into their unique characteristics, understanding how their mass influences their brightness, lifespan, and ultimately, their fate. We've encountered examples of these titans, like Scooty and VY Canis Majoris, names that now echo with a sense of grandeur and scale. We've traced their life cycles, from their dramatic birth in nebulae to their fiery demise as supernovae or hypernovae. We've seen how these spectacular endings seed the universe with heavy elements, essential for the creation of new stars, planets, and even life as we know it. And through it all, we've gained a greater appreciation for the complexity and majesty of our universe. Remember, the universe is full of wonders, and the most massive stars are among its most awe-inspiring sights.